Hey, this is Alex. I'm here at Aeroscope Labs. Today we're going to talk about isolation. So, isolation, what does that mean? Traditional oscilloscopes, there's a direct connection between the ground on the oscilloscope and mains ground. So this means if you're probing a circuit and you're not careful, if that circuit is also not isolated, and you're not careful where you place this ground, you can cause circuit problems, you can short things out. With Aeroscope, it's wireless and battery powered, so there's obviously no connection to mains ground. This is advantageous for several applications, one of which is switching power supplies. So we're going to talk about that today and show you how this works. So we have our switching power supply module set up, and we're monitoring the current through the output inductor using Aeroscope. You can see on this waveform on Aeroscope screen that the current's ramping up to around 250 milliamps and then ramping back down to around negative 200 milliamps. This is a really important waveform to look at when you're doing switching power supply design. This allows you to make sure that you're not violating any of the current specs for the controller or the inductor. You can also make sure that you're not violating the saturation current for that inductor. Next, we'll show you some problems you might run into trying to replicate this measurement using a traditional oscilloscope. Aeroscope's now monitoring the output of the switching power supply. We're going to try and recreate that measurement that we did previously using a non-isolated oscilloscope. You can see that as soon as I touch the ground to this switching node, the output falls down to 0. It's getting shorted out. You could get around this problem by using 2 channels and doing math, but it's just far easier to use an isolated oscilloscope for these kind of measurements. We hope that this demonstration showed you how isolation can be an important feature for certain measurements. Stay tuned for more updates.